Hello everyone, welcome to the LK Ravi Tech Show. Today we are going to discuss about Terraform. First of all, little bit about me. I am Ravi. I got 10 plus years of experience in technology industry by working through various roles ranging from software engineer to tech lead. Last 4 years specifically, I mostly focus on DevOps and SRE space. And with regard to Terraform, I am HashiCorp certified Terraform associate and working with Terraform day to day to manage production infrastructure. Without further ado, let's start. This is our agenda for today. We are going to discuss about what is Terraform and how it works. Then we are going to discuss about the basic concepts of providers, resources, data source, output, variable, locals, and what are those and how to use them. Then we are going to discuss about some scenario based use cases, how someone can start using Terraform and what are the pitfalls and how to overcome them. And then we are going to discuss about the best practices and couple of important concepts that we need to know when we are using Terraform and couple of troubleshooting tips. What is Terraform? It's a tool for infrastructure provisioning. We know that Terraform is an infrastructure as code tool that let you define your desired infrastructure in a human readable configuration file that you can version, reuse and share. It's open source tool and it's declarative. What it means? So we just need to define the result we need and no need to define every step of how it's done. Why Terraform? In here I state manage any infrastructure. So reason, there are thousands of providers plugins available for most of the platform and services. So in case of unavailability of provider for that particular platform or services, if it is have API, that we can create our own one. So if you check the Terraform provider page, you can see almost all the platform and services maintaining Terraform provider for it. So it's safe to say we can manage any infrastructure. Track your infrastructure. Terraform keep track your real infrastructure in a state file, which act as a source of truth for your environment. So it's really helpful. So it not just creating your infrastructure and kind of fire and forget way. So it's keep track of your infrastructure in a state file. So we can see what we have created. We can do the comparison and it's track your infrastructure. So automate change and also as we discussed, Terraform configuration file are declarative, so we don't need to write step-by-step instruction. We just need to define the desired state using the Terraform configuration. So then the Terraform will make sure that it will do the required provisioning for us. Standardized configuration. So the Terraform, it support reusable configuration component called modules that define configurable collection of infra. So using that we can standardize industry standard, or we can group together the way we need how that infrastructure should be, and it save a lot of time and encourage the best practices. And also the collaborate. So all the configuration are written in file, so easy to manage. It's so we can put all this code in any version control system and it's easy to collaborate. Yeah, how it work? So as I discussed earlier, Terraform create and manage resources through their API. So these providers enable Terraform to work with virtually any platform or service. That's why we mentioned that we can almost automate anything because there will be a provider for it, and community, if there's no provider, and we can create it, or else there's active community and they are keep building and automating new providers. So in the Terraform there are a couple of steps that we need to do. There will be, we will be writing Terraform in the Terraform configuration file, and we will see how it's done. So once we write the configuration, we can just initialize that configuration, and it will download all the required providers uh, to your working directory, and then you can do the Terraform plan. What it does is it's go through your configuration and plan what are the infrastructure that we are going to create, and it gives you a plan, and you can analyze and see, okay, this configuration will create this infrastructure, and you can visualize it and see what are the resources you are going to create, and what's its configuration. So if you are okay with the Terraform plan, then you can go ahead and do the apply. Once you do the Terraform apply, it will be create the that respective resources in the cloud provider or services that you define. Yeah. So like in the first example, we can just define the provider. So Terraform configuration files, we can define like the file name with .tf extension. So then Terraform identify it as a configuration file. So for example, in here we are just defining the AWS provider. You can see what is the available parameters by referring the respective provider documentation in Terraform. So basically in here we are defining what is the region, and here the version constraint that we are defining. So what are the version we are allowing to use this provider, why it's important. So Terraform let us specify the range of acceptable version for something, for example modulo provider. So it's especially formatted string known as version constraint. So we can define major minor patch version. So what up to what extent we are allowing to provider to handle the automatic updates. So we can discuss those things later, but you can read more about it. When it comes to production, managing production infrastructure, it's really important because with all these providers, basically it's API driven. So with the new versions, there will be some breaking changes with the major versions. So you cannot just go blindly on the new version. So that's why that it allow us to control what are the version that we need to have defined in this our provider. So once you test it in a low environment like your dev and pre-prod environment, so if everything is okay, then you can go ahead with the respective version for the production as well. So this is how you can control the provider version. And yeah, once you define the provider, you can run the command terraform init. So in the terraform init, what it does it download the that respective binary into your working directory. For example, in second example that you can see, once I in the demo1 folder, initially there's nothing, only the provider.tf available there. So once you define it and once you initialize the Terraform, that means run the Terraform init command, then it's download the that respective provider into your working directory. So that's the binary that's Terraform is using to communicate with respective platform or service. Resources. Resources in Terraform represent a thing in real world. So resource block allow us to define how you want to create something in real world. For example, in here, so the initial file we define the AWS provider. Now using that provider, we are going to create the AWS instance. So we can just using resource block, we can define the AWS instance with whatever name we need to define, and we can provide the parameter. In here basically we are providing the AMI instance type, but if you check the AWS instance resource documentation, you can see what are the all configuration that you can do in the AWS instance. All the CPU count, memory allocation, everything. So yeah, in here one important thing to note. So in the earlier that we just define the provider and we run the Terraform init, and it download the binaries to our working directory. So now once we define the resource block here using resource AWS instance, so we can run the Terraform plan. So then it will prompt us, okay, what it's going to create. Then if you are okay with that, once we run the Terraform apply, something special happen. So it will create once it create the AWS instance resource in the cloud provider, and also it created Terraform state file. So currently we are using local state by default. Terraform manage state in locally, but we will discuss in future. So what is the best way to manage Terraform state in a team environment? So for the moment we will keep it as it is. But if you see, open and see the Terraform state, you can see now in the main TF we just only have the AWS instance, and Terraform state under resources we can see the instance we have created and all the attribute associated with that instance. So that's how Terraform keep track of the resources you are creating. So no matter how much all the resources you are creating, it's tracking inside the Terraform state. Data sources. Data source in Terraform used to fetch data from resources that not managed by the current Terraform project. It's like a read-only resources. You can read all the attributes related to that resource, but you cannot do any modification. Basically, it's not create to update, just a read-only resources. For example, in here I added as a data source for AWS S3 bucket. In my account I have a bucket called Keravi demo1. So I need to access some of the attribute in that bucket, so I use it as a data source. So I put data AWS S3 bucket and with the bucket name, then do the Terraform plan and update. So you can see in the Terraform state file, if you see it, now we have under resources it's tracking the S3 bucket as well. So I mean all the attributes associated with that S3 bucket, I can read it from the Terraform state as well. So if you add it as a data source, all the attributes like ARN, bucket domain name and everything, if you need to access those attributes for some other purpose, reference as a reference for some other resource, you can access it. Yeah, outputs in Terraform, output values are like function return value. So output make information about your infrastructure available to command line and can expose information to other Terraform configuration. For example, if you are um, using Terraform modules to communicate with these modules, pass value to in between, uh, so we can use output. uh, Basically, yeah, it's similar to the return values in programming language. In here, we, for example, we are just defining the bucket ARN. You remember that I added S3 bucket as a data source, and now I'm referring the data.aws S3 bucket and the bucket ARN value. And for the instance we created, I need to get the instance private IP as output. So once I define these two output values and run the Terraform, apply. After apply, it's as the second screenshot, it output the bucket ARN and the private IP I define. So for example, like this use case, sometimes there will be different circumstances and you may need to get some output to a console or different module. So in that purpose, you can define the output values that you need to get like this. Variables. Yeah, input variables are like function argument. So passing dynamic values to runtime, we can there are several types that we can use with Terraform. The basic string, number, and boolean type, and also the like list, set, map, and object, tuple, or this complex type. In the Terraform documentation, you can find how to use all these types. Just as a brief, in here we can, for example, previously that we are using that, creating that AWS instance, and we just hard coded the AMI value there. Instead of that, if we need to provide the image ID dynamically, then we can define image ID variable. If you prefer, you can give a default value as well. It's not mandatory. And if you need to validate it, you can do then and there, like this. In here we are just validating that started with the AMI using the length and the substring. We just substring it and check the first four characters start with the AMI dash. So this kind of validation also we can do. And also the for instance type, we are just defining string variable, and we are also setting default value. So once we define the variable as a Terraform configuration, there are many ways that we can pass this variable dynamically. For example, we can pass it as a command line argument. When we are doing Terraform apply, we can just type -y equal the variable with the value like a key value, and we can also put all these variable into the variable file. We can define them as a with the tfvars extension and pass it as a Terraform apply -var file as a var file. And also we can configure them as an environment variable. So all these methods available, and here there will be variable precedence. You can see which take first, the environment variable and the tfvars, and so and so. Locals in Terraform, local value are like functions temporary local variable. For example, sometimes that we may need to define some expression uh, just for that in that configuration context, that we may need to use multiple time without repeating the expression. For example, most commonly this tagging example, if we need to define some expression and use it in all the uh, resources, we can just define it as a local variable and then use it wherever we need, like this example. Okay, let's move to some scenarios, and here we are going to discuss about uh, this architecture. So he's Sam and he's tasked with creating cloud infrastructure for this architecture. He new to the Terraform. He just finished his basic learning about the Terraform, and he's going to do this architecture in AWS. So there will be one availability zone with public and private subnet, and he just need to have web server in private subnet, and the Bastion host in the public subnet to manage the resources in private subnet. Let's see how he approach this problem. So Sam initially tried things in the staging environment. So he created, so he decided that he need to have a VPC, virtual private cloud, with public and private subnet. He initially tried to go with the public subnet with Bastion host. Bastion host. So he created the VPC and the public subnet and the Bastion host like this in the single configuration file. So he just defined all these value CIDR block for the VPC and the public subnet, and the same as the AWS instance we discussed previously. He just provide the AMI instance type and everything. So you can see everything for hard coded, and he initially trying with this example, and everything working fine. He just created the VPC and everything. So when he working on this his initial trial, he got some instruction from his team that we need to have production Bastion host as well. So in the working environment, that's how thing works. So you don't have, when you are doing trials, suddenly you get some requirement changes and you need to move on with that. So he decided that since he already created the tested the staging infrastructure, and it's went well, and he created the VPC, public subnet, and the Bastion host. He just decided to get a copy from that, and he renamed it as a main.prod and main.staging, that his previous file, and he get the copy, and he just changed the variables like CIDR blocks and everything accordingly for that production environment. So far everything okay. He just run the production Terraform code, and he created the production environment. So one thing to note, you can see that he's both the main prod TF and the main stage TF files are in the same working directory in here in demo2 folder. So next, Sam got another requirement change because in for staging initially for his trials he just used arbitrary cider block, but as an organization policy when he's working with the team he realized that okay he cannot use this cider block and he need to get allocation from the networking team, and he got this new cider block and for the staging environment, and he need to now change. Previously he used 10.00 dot slash side. Now he need to change it to 192.168.0.0 side. So he's since he already tried this now with the staging and production, and this stage only is for staging environment, he's pretty confident with it. He know it's just a side block change. uh, for safe side he just he doesn't want to do any changes to production, so he decided to back up the product configuration file. He just renamed the main.prod.tf file to main.tf backup, and as a backup, and in the main staging file he just do the changes that he need to do. So since he now try with the staging and production couple of times, he's very confident. He didn't bother to run the Terraform plan again and again and verify, because he know that this he's only changing the side block, and that's also in the staging environment. So without verifying anything, he just run the Terraform apply with auto approve. uh, and so let's see what happened. Whoops, looks like I lost my prod environment. Someone deleted it. So what happened here? So if you can see, as a safe side he backup his production configuration file. He didn't realize that he's managing both the environment main.prod and main.staging in same work directory. That means sharing the same state file. And if you change the tf configuration file into some other name, Terraform will no longer identify it as a Terraform configuration. And since you having your production infrastructure in your state file already created, but currently you don't have configuration for it because you rename the file, then next time when you run the Terraform, so what happened, Terraform detect okay, uh, previously I got this configuration, now I don't have this production configuration. That means I have to destroy the production environment. So if even though he did it, if we go through the proper process like Terraform plan and see what it's going to do, and even with Terraform apply, if we review the changes he's going to do, then he's going to find out. But he didn't do it, and he go with the change with the confident. Now he lost his production environment, so he learned the lesson in a hard way. So let's see what are the issues having in current design. So first thing we discuss, sharing a state file for multiple environment. So in here we having same state file for production and the staging environment, so it's not good. So all configuration file, all configs in single file. So let's say we have only the main tf file and we are managing all the network here and all the best subnets and the resources here. So when it's growing, so it's difficult to manage. so it's better. We can improve that. And also we notice that hard-coded configs, that all side values and instance type, AMIs, everything hard-coded. So previously we learned that we can use variables, and we can improve that. And also currently all these production and the staging state, so it's managed locally, so it's not good. So if you are working in team environment, there will be some challenges on sharing your state file. You cannot it's not recommended to commit, push it to your source code managing system, because it may contain some sensitive information. And also uh, there will be conflicts if multiple people try to use the same state, and managing in a source code repository is not a good thing to do. So we need to improve that. So we can have different solution for that. So let's see how we can do these changes. Yeah, in next sprint he decided, okay, he's going to do these changes: separate state for each environment, refactor config to multiple file, and use variables. So Sam decided that he need to have different state file for this environment. So he just separate it out by creating two different working directories for prod and staging. And in there he just defined the network, all the VPC and subnets in the network TF configuration file. So he break down the single config file to multiple. So and the rest of the VM into the vm.tf. And also he defined the variables for the VPC side, the availability songs and private subnet, like the, and he put all these variables into respective TFR variable file. He got now two variable file, one for prod.tfr, one for stage.tfr. So he can put all the appropriate value for that respective environment there. So yeah, main three issues that now we have resolved. That now he got separate state file for prod and staging environment, and break down the config file into multiple files, and start using variable. Yeah, there are still room for improvement. So as we can see in here, we are lot of code duplication, that we are we are using same AWS VPC and the public subnet, same code again and again in the both folder. The configuration is repeating. And if we got any other environment, any other testing environment, and it will be difficult to manage all the same configuration in different environment. And if you manage like this, there will be configuration drift. So it's not good. So what we can do? So Sam decided to create a module for network. So as we discussed earlier, module is a logical grouping and similar set of resources that we need to create, and we can define the standard there, and we can reuse that module. So instead of having same code repeating again and again in the module, we can define all the network related code, and we can define the inputs, what are the things we are going to get as an input, and the output values. We just need to get that from module. And in that environment we just need to define the uh, uh, that respective module, like with the required variable. For example, in here, uh, let me show you. If you can see here, so we got production and staging, two environments, and in module we can define all the network resources here, and as an input variable we define what are the inputs that we need to get for this module, and we define the output values we are going to output from this module. So once we create the network, we need the VPC ID and the subnet IDs, private subnet and public subnet IDs. So we are just outputting those value here, and how we use this module in our environment. For example, in here production, if you see the main file, now we remove all these network resources from here and we just define the module here. So it will refer the module network we define under module network folder, and we are providing the required variable for that module. For example, production environment, we are providing VP cider and respective value for production. So in the prod TFVR, we define the values for production. So now it's elegant and we are not repeating ourselves, and we only define our changes only one time here. Yeah, so that's the improvement we have done. And yeah, one more thing I need to show you. Yeah, so previously we had another issue that we are defining the state file locally. So in our earlier example, we just having the state file in our local demo 1 and demo 2. So we discussed that it's better to have our state file in the shared location that everyone can access. So in this case, you are seeing S3 backend for the state file. You can define the you can create S3 bucket, and you can define the bucket and the key for the state, and your state will be saved in the S3 bucket. So we will be discussing the best practices when it comes to state file in future slides. So we'll discuss more about that. This DynamoDB table, so some of these backends we can define way to manage the state lock. State lock is to prevent multiple people writing to the state file at the same time. So then a state will be corrupted, and those state files are our source of truth, right? So we define it's track our configuration, what we are creating in any cloud provider anywhere. So only was one person allowed to modify in a given time. So to manage that state lock, we can define DynamoDB table in S3 bucket concept. When it comes to, there are several backends available, GCP and when it comes to GCP bucket, it by default support the state locking, so we don't need to have any other mechanism there. But in S3, if you are doing that, we need to define DynamoDB table for that purpose. So this is how it's done. Okay, back to our slides. So in this scenario now we cover how to modularize it and prevent the and improve our code by reusing it, and also we cover how to use a remote state, all these things, separate state for each environment, refactor config to multiple files and use variable, and also the how to migrate local state file to a remote state file. Okay, so yeah, some of the best practices that we can define, we can discuss here. So shared remote state file, so we just discuss it. So when it comes to Teams environment, obviously we need to have a central secure way to store our state. So there are several ways of backends available. So in Terraform site, you can see what are the available backend, and based on your requirement you can choose one. And also that if that backend by default doesn't support the state locking, then you have to configure that to prevent the corrupt your state. For example, in S3 bucket context, that we need to use DynamoDB table to manage the state locking. And also some of the backend we have to backup state file regularly, because if you lose your state file, it will be very difficult to recover from it, and you have to again rebuild your state from the scratch by importing raw resources. It will be tedious task to do. So it's always good to have a regular backup. For example, if it is a S3 bucket or GCP something, you just need to enable the versioning on your bucket, so then it will work as a backup, and it will maintain all the versions. It will be maintain the older version, so it will work as a backup. So you will be good with that. But if you are using some other backend that doesn't have that feature, then you need to think about setting up some way to backing up your state file regularly. This is very important. Treat your infrastructure as code as same as your application code. So as a developers, normally how you treat your application code, so you collaborate it in your you commit everything in your source code repository, and you using proper branching mechanism, and you have proper mega checker approval process and everything. So same thing, it's applicable for infrastructure as code. So if you follow the similar principle, it will be you will be in good position to manage your infrastructure. So we discussed the reuse code with Terraform modules. So it's always whenever you see repeating code, and if you see that you can modularize it and reuse the code, then it's better to do it. And obvious that they do not hard code things and use variables. Sometimes maybe it's not a variables, sometimes it's a local expression that we discuss. So whatever appropriate, instead of hard coding, you can just use these features. And also important thing that we can we when we are doing Terraform, apply that whichever the service account or the user account associate with that Terraform profile, that we need to have permission to create that infrastructure in that particular cloud platform, right? So it's always recommend to have a minimum permission for some. For example, you are managing only the EC2 using Terraform in your cloud provider, but you are associating admin level permission for any resources for that cloud provider. So if you compromise the service account, or your probably a CI/CD platform, so it's very powerful that exposing this infrastructure as code service account, because it can do anything. It can create and delete any resources. So be mindful about that. Always use required minimum permission on service account. And you may wonder how to find out, okay, what are the actual required permission, minimum permission, when you're working with Terraform, because you may creating several resources, and you may not know granular level permission. So in this article I have discussed how to find let me open it. Yep. Sorry. Yep. In here I discuss all these best practices in detail. You can subscribe me in Medium, lkravi.medium.com. In yeah, how to use shared remote state, and the how to use locking, and all these things we discuss. Importantly, yeah, this one, how to use minimum required permission. So with the Terraform, logging, you can enable the trace, and like this you can trace all the API calls, and then by uh, grabbing all the debug request, and you can find out what are the actual API calls that you are making to a cloud provider, and using that you can find out what are the granular level permission. I'll show you this in more detail in upcoming slide. So that, yeah, that's one important thing. Yeah, couple of useful concepts. Implicit versus explicit dependencies. So implicit dependency, it's like as their name suggests, that automatically detected by Terraform. So when it come to creating multiple resources, you, you know uh, there will be always challenge, which resources should come first, and also when destroying, which one we should destroy first. And so if there's an obvious relationship, like in this first example, in the implicit dependency, so we are just creating the AWS instance and the elastic IP. And for the elastic IP, to have it, that we need to create the AWS instance first. So in there, as you can see, so since we are passing that AWS instance as a parameter to elastic IP, so that AWS can Terraform can detect there's an implicit dependency, that's obvious dependency, and based on that, Terraform can generate the dependency plan, and it's know which resource should create first and which come next. But there are some situations that we cannot see, I mean hidden dependencies where it's not obvious and we cannot see from the outside that there's a resource dependency between these two resources. And when it comes to complex infrastructure with hundreds of resources, there will be a lot of edge cases when it comes to creating and destroying if we didn't manage these dependencies carefully. So for example, in here, let's say we have S3 bucket and the instance, and by infra level we doesn't have any dependency on it, but logically we know that we need to have this S3 bucket created first, because we are using uh, that S3 bucket to initialize something in the AWS instance. So in that case, uh, we can explicitly define the dependency using this depend on keyword. So we can define, okay, this AWS instance is depend on this S3 bucket. Likewise, we can it can have multiple resources. So this is really important to see the define the dependency when it's hidden and it's not obvious, so that Terraform can get some insight and it can generate the dependency plan based on this. uh, so I like to show you how we can utilize this demo for. Yeah, if you type Terraform graph, that you can see this dependency graph, uh, not as a graph but in the textual format. But if you need to generate the graph, you can use some other tool like dot, and you can generate uh, the graph like this, for example. Sorry. Yeah, like this you can generate the dependency graph visually. uh, as you can see in our previous example, uh, we have this uh, VPC, the module network, and it depends on all the variable, and availability songs, and the private subnet, and the instance we are creating its own private subnet, and the bastion host, it's depend on the public subnet. And likewise, Terraform can identify and generate this graph. And when it come to complex infrastructure, and when you're troubleshooting some dependency issues, this diagram will be helpful to identify if there's any corner cases or edge cases. uh, for this dot utility, I'm using this graph is utility, so you can install it and uh, use it to convert the Terraform graph to the uh, visual representation. You can generate any PNG, SVG, or any image using this. Yeah. Yeah. Importing existing infrastructure to Terraform. Yeah. So sometimes that we can use import command to get the pre-existing cloud infrastructure under the Terraform management. So there may be circumstances that there are some resources already created and it's not managed by the Terraform, and but now we need to get them under you know Terraform management. So in that case, we can use Terraform import command. So in here, the current Terraform version, it's not creating the resource block for you. So you have to define the resource block first and then import that particular resource. For example, if you need to import any particular instance, you need to define the resource block for that particular instance, and then you can import. Very important thing, you have to verify once you have important by running the Terraform plan, because there may be configuration drift between what you define in the resources and the existing infra. So if you are not verified changes, uh, so there will be some issues. So once you define the resource and then you import it, you can run the Terraform plan and see is there any changes. So if there's any changes, then you have to add those changes to your resource block, those attributes. Until you have zero changes, you have to do the adjustment to your defined resource block, to import this smoothly. Yeah. Troubleshooting, as I previously mentioned, that we can use the Terraform logs. There are several verbosity levels like trace, debug, info, warn, error. Based on the information you need, you can enable the debug level. For example, previously I mentioned to you that we can use we can find out the granular permission that we need to grant for the Terraform service account or the user that we are using to execute the Terraform code. So when we apply the Terraform, we can just enable the trace and write all the log into log file. Then just analyzing that log file. In here you can find out all the API calls it making using grep debug request, all the requests it making using this debug request, and you can grep it and find out the endpoint it's try to communicate. For example, in our example source code we have created in the demo 3 and 4, it's just need these easy to create subnet, to create VPC, and all these endpoints we are defining here, it's calling during the Terraform execution. So by using this method, we can accurately identify into the granular level, so what are the exact permission that we need to grant, for example Terraform code. So one time you can run with admin permission with the Terraform apply and find out this log, and then you can delimit your permission policy to grant only what you require. Okay, yeah, these two things, the taint and taint, also help to mark the resources that are not fully functional. So then it will be deleted and recreated. There will be circumstances that your Terraform code executes successfully, and it saying that resources is created, and in the cloud environment also you can see that resource is created, but still you can see there are some issues and it's not working properly. And since if it's updated the Terraform state, and if you run the Terraform code again and again, since it's already created, nothing will happen. But if you need to recreate it, you can use this Terraform taint command. Let's say this VM1, you just need to recreate it. You can mark it as Terraform taint plus the resource. You can specify the resource, then it will mark it as a taint in your state, and when you run the Terraform apply next time, it will recreate. Also you can use untaint if you change your mind, and if you no need to untaint the resource already tainted, then you can use the untaint command. Yeah, this state command also useful when it comes to troubleshooting and find out issues. So Terraform state list, you can find out all the resources that tracked under your current state, and if you need to see specific resources, you can do it like Terraform state show with the resource name. And there are some circumstances that you may need to remove some of the resources from the Terraform state. For example, when someone manually deleted outside of the Terraform, and but it's still tracking in your Terraform state. To avoid the confusion, you just need to remove it from your Terraform state safely. So at that kind of scenario, you can just use Terraform state remove. But yeah, manipulating state file, it's not recommended. If you know what you are doing, then it's fine. But if you are not sure what you are doing, then it's there will be consequences. So you have to be very careful when you are manipulating the state file. Thank you for watching till the end. You can find all the code example in this GitHub repo. Also, follow me on Medium and subscribe my YouTube channel as well. Please do comment with your questions, suggestions that will help me to improve this video series. Thank you very much.